get some data, and this data will be very beautiful, and we will use them and do them this and that. It's not like that. IoT, to design IoT system to be impactful and profitable, it's important to design it beforehand, to make the correct decisions. Otherwise, if you have a large amount of investment, many times you will not have the return of investment. The return of investment, not money-wise, but the impact we expect from that will not be as expected. Impact to your business, impact to the environment, to the society, etc. So the design and the selection of Internet of Things sensors and how the network is working and operated is very, very, very important. So let's take an example of a typical city which has a lot of sensors inside it. We have air pollution, measuring the air pollution. We have air pollution. We have forest fire detection. We have structural health monitoring for our bridges or houses or other structures. We have perimeter access control, radiation level measurements, for example, electromagnetic level measurements, traffic congestion and traffic management, smart roads, smart lighting, intelligent shopping, noise urban maps, to map the noise around the city, which depends on the traffic and many other things. Water quality, water that we drink and water in the sea. Waste management, smart parking, water leakages, car auto diagnosis, item location. Okay. There are so many things that we have in a smart city, either at the item level, car level, environment, congestion in the streets, perimeter access control, etc. As we talked before, a typical IoT architecture is the 4-layer. However, the 4-layer is very simple architecture. We have another layer called the business layer. As we talked before, in order for an IoT system to be profitable, to be impactful, we have also the business part. So business layer, business logic and rules for IoT system behavior, responsible for setting the system's overall objective, workflow, and policies, uses data processed by other layers for actionable insights and decision making. So we get all this data, and that data that we get after the analysis, it helps our business to have some decisions. Decision about the environment, decision about our sales, decisions about our action. So IoT, so by doing this, what we have is IoT actually translates to tangible business value. And it is crucial for enterprises to improve processes, enhance customer experiences, and generate new revenue through IoT solutions. As we talked before, edge computing is very important. Why? Because it has localized data processing. It reduces latency. Latency is it means how fast a sensor reacts, how fast we react to a measurement, okay, and how fast we react. So by having edge computing, it helps for the bandwidth optimization, it improves the performance, it reduces the server load, and the so-called real-time processing for the Internet of Things. Real-time processing, it means instantly. Let's call it instantly. It's important for the edge computing. At the same time, imagine if we have self-driving cars and we have to upload the data to the cloud, process the data to the cloud, and then decide if, for example, a pedestrian is in front of us, is in front of the car. So it will be too late. Why? Because we might have latency issues. It might be slow. It might be disconnected. So it's important for us is to process data at the edge, data which is crucial data, which is vital data, to process them before they are uploaded to the cloud. And we can do this through edge computing. So not everything should be uploaded and processed in the cloud. We also have 6 layers. One of the 6 layers, I would say, is the edge computing, but actually, according to the IoT World Forum and the IoT reference model, remember the 4 layers I showed you before? The IoT World Forum, they say that they have 7 layers. The physical devices, the connectivity, edge computing, data stored here, data are accessed. We analyze the data, and then after we analyze that data, we have business doing something with that data, evaluating the data, taking action with that data. So this is the most modern, up-to-date thing related to that layer for Internet of Things. So as you understand, it's not just a sensor connected to the internet, it's many, many things. And at the top there, we have collaboration and processes involving people and business processes. As we talked before, a typical home is like this: smart home, IoT gateway, etc. And then we have different topologies. We have ring, we have mesh networking. Remember that mostly these Internet of Things are wireless. We have star connectivity, fully connected. We have tree line. So what kind of networking and connectivity are we going to use? Is it going to be mesh, star? Or is it going to be like this, which is a typical for a smart city? It's a combination of all of this. You have multiple gateways, you have star, you have mesh. So by having a mesh, so if you have a star like this one here, if we have a star like this one here, if this breaks down, then all of these sensors here, they don't work. With mesh, if this breaks down, then this sensor could redirect the data from here, here, here to the internet. So mesh networking and all these depend on the application. So if it's a vital application, it's very bad idea to use single point of failure. If it's a remote patient monitoring system, and you have a single point of failure, then there is a danger that we don't get that vital data. Or imagine if these are cars and moving around the city, and one of these gateways here breaks down. What happens? So the design of a correct design of a typical IoT system is very important. How do you design the system? You can see here another real example. Smart emergency response system. So as soon as the ambulance or the fire brigade approaches the traffic lights, you have sensor there to sense that there is a fire brigade coming or an ambulance coming. Then the lights or the traffic lights will change to green and allow the fire brigade to go through. Okay, and this is done usually at the edge. Okay, they don't have to process go to the internet, to the cloud, and then process and go back. Okay. For weather monitoring and etc., if to have something like a couple of minutes delay or a couple of seconds delay if it rains or the temperature, these data don't change so fast. So so you don't really need real-time processing. Okay. So these are the things that we have to consider as important for design when we design an Internet of Things system. Scalability, security, interoperability, data management, reliability and availability, and the list goes on and on and on. Energy efficiency, cost effectiveness, regulatory compliance. We have EU regulations. We have different frequencies here in the European Union. You cannot get something that works in the United States and install it here in Europe. Okay. They will not allow you. We also have different protocols, different powers here. How do these things connect to existing systems? Imagine that we want to measure leakages in our water at the water authority. They already have systems there. How do we connect these old systems, which are 10, 15, 20 years old, to the new system? They have to collaborate. They have to talk to each other. And then what happens with sensors? How do we select sensors? I showed you before a sensor which for the measuring the temperature and humidity, which is 10 euros. Okay. And at the same time, you can have again Internet of Things sensor, instead of 10 euros, 200 euros. So you can measure the same thing, but they are not the different. The accuracy and precision is not the same. The energy efficiency is not the same. That small sensor has a small battery and it can go for 1 year, and then you have the expensive sensor and it's much more accurate, more processing power, more distance, but it needs a lot of power. Response time, data transmission rate, range and sensitivity. Bluetooth is 10 meters, Wi-Fi is 100 meters. Bluetooth is low power, Wi-Fi needs a lot of power. You have LoRa. LoRa is very low throughput, very low data throughput. Wi-Fi is very fast on the other hand. Do you need to be very fast? Or slow and low power is good? So depending on your application, you will make the required selection. So same measurement, temperature, but if it's for process control, for an industrial IoT, for measuring a process, if it's for a rocket going to space, it's important to measure the temperature in real time accurately, for example. If it's temperature in our greenhouse and the data rate is every 10 minutes, it's fine. Connectivity and network reliability. Usually, one of the best things that we have to follow when designing Internet of Things network, it's important to have the so-called end-to-end encryption. And that means that we have encryption from the sensing, from the actual sensor, till the cloud, or better say, till the user. Okay. So here we see that we have 120-bit encryption, 128-bit encryption. We have here TLS HTTPS. We use MQTT TLS 1.2. These are security standards and security protocols for MQTT, for HTTPS, etc. And then we have also the IoT application here, again, secure. As I mentioned before, we have to measure the cost effectiveness. 94% of business who have implemented IoT strategies, and I mean correct IoT strategies, they have seen a return of investment. And another 6% who have not implemented the correct strategies have not seen a return of investment. So it's important to be not to be in the 6%. Okay? Because at 6%, if you invest thousands of euros and you have a smart city or a smart home and you are within the 6% because of wrong choice of gateways, wrong choice of sensor, wrong choice of platform, etc., you will never get your money back. Okay. So it's important. So it's important. And this is the most important thing. That's why I left it last. Impact the return of investment, the return of investment, economic viability of the project. It's important for any project to be economically viable. Okay. Some will say, but it's for the environment. So if it has impact, then and the government, local authorities will invest to have social impact. So it's not always economic impact, it's environmental impact, it's social impact, it's health impact, but usually it's economic impact. And then we go to a little bit more to the hardware level. The operating system of IoT devices. Yes, the IoT devices have operating systems, like your Android phone, iOS phone, Windows 10, Windows 11, Linux. The IoT also have they have operating systems. We have TinyOS, free RTOS, VxWorks, Zephyr, RIoT. We have also Apache here, Apache from Apache Foundation. You have ARM embedded. There are Android things. You have also Google here. Google tries to have its own operating system on the called Android things. You also have Windows IoT. Condigi is quite important for many of these. So you also have operating system. Operating system means the software that the Internet of Things device is using. If we want to modify the upgrades, the stability, the power consumption, etc. So devices, the IoT devices, the selection of the operating system depends on what is the energy efficiency of that IoT. We all know that we have our mobile device. It is running on Android, for example, and the power consumption of Windows is much, much more, okay, compared to our Android device. So energy efficiency is important thing in when designing an IoT. It should have a tiny memory footprint. If it has a large memory footprint, it means larger cost, larger amount of processing power, and more processing power, it means more power consumption. Usually it's good if we have real-time processing, and for sure it should be secure as well. We don't want someone to modify easy our hardware. But that was to the very, it's important for hardware designers. Another thing that we have to consider when selecting the Internet of Things device is the speed and data rate. It's the range. Range could possibly be, range and power consumption could possibly be the most important thing for normal users. So is it going to be 10 meters, 100 meters, or 10 kilometers? Is it within our house and 10 meters is enough? Is it in our garden and 100 meters enough? Or is it somewhere outside in the fields and we want to measure some parameters in the fields for smarter precision agricultural purposes, and we want 10 kilometers range for that sensor? All of these sensors are measuring the same temperature and humidity, for example. Power consumption. Is it going to be powered by mains, by battery? How many years does the battery last? How many months does the battery last? Is it rechargeable? Cost. Cost, most of the time, is the most important part, as well as the network topology we have seen before. So one of the most important connectivity methods that we have in our houses, and we use it for wearables and other things, is Wi-Fi and Bluetooth. Okay? Wi-Fi and Bluetooth. Zigbee is very important for smart homes. It is low power, low bandwidth, and maybe 10 meters, let's say. Okay. NB-IoT, it is offered by mobile telephony operators. Narrowband IoT, it's called. Okay. So usually this is quite expensive. You have to pay a monthly fee to the telecom operator. Do you want to pay €5 per month for each sensor because it is connected to the NB-IoT network? Maybe not. So maybe it's much better if you buy a sensor which uses Wi-Fi and connects directly to your home, and without need to pay NB-IoT. Or even 5G. Or GSM. One of the most popular protocols, transmission protocol for connectivity is the LoRa. LoRa gives the ability, because it has high penetration and long distance, it can, it has a range up to dozens of kilometers. So you can cover a whole city using a couple of LoRa nodes. And at the same time, for applications that they are outside in the fields in rural areas, LoRa could be a solution. There are some popular networks out there. The one is called the TTN network, and there was an effort a couple of years ago, and we still have, to combine the LoRa network with cryptocurrencies, and they made some. It's called the Helium network, and it's using LoRa. So the intention of doing that was to cover wirelessly through LoRa, and now you have dozens, hundreds of thousands of LoRa gateways around the globe that people invested in. Each LoRa node was 700 euros or something, and it's good. It could be a good idea to utilize this network. However, I would say that because it's based on crowdsourcing on people that they have installed on their roofs, I would not consider it as quite as reliable if you have important applications and vital applications. Okay. So we have, as you can see here, you have maximum range here, 100 kilometers. We have satellite here. Satellite IoT, you will laugh now, but satellite Internet of Things, it is considered as a possible solution for large cities. Instead of installing dozens of beacons and gateways around the city to measure things, you can have satellites going around the globe everywhere, and you can beam to these satellites every 10 minutes, every 1 hour, the beam level or the water level or other things that are not so, they don't need real time, etc. So LoRa is here, and NB-IoT is here, and Zigbee is here. Okay, Bluetooth is here, Bluetooth 5 is here, so up to 100 meters maximum. Okay. We have talked about this, Zigbee and LoRaWAN, a long-range, low-power protocol for wide area and IoT network, often used for applications like smart cities and agriculture. NB-IoT, Wi-Fi, Bluetooth, etc. And here you have a table with the Bluetooth optimized for battery life, for example. Wi-Fi is not optimized for battery life. Local, less than 100 meters. LoRaWAN goes more than 10 kilometers. It is slow, however. So for things that they don't change very fast, LoRa is good, as well as NB-IoT is good. And the other things here, 2G, 3G, etc., they are very powered. They need a lot of power requirements. You need to pay all these telecom operators, and there's no real need to go for that. So I would say that most popular ones are Bluetooth and Wi-Fi, and these things here. And if you want, you can use a gateway, 4G gateway that it has Bluetooth Wi-Fi on it, so you can connect sensor through Bluetooth and Wi-Fi to the 4G and then to the internet. So there is no one-size-fits-all protocol. This is what I said before. MQTT, protocol purpose made for IoT, are seeing increased adoption. Ease of use and reliability are most important when choosing a new protocol. I would say this is the most popular one for IoT. Okay. This is not good for IoT. It's not popular with IoT. This is okay as well. But I would say that this is most of the organizations are using the MQTT protocol. The MQTT protocol has a header of only 2 bytes. The message size can be up to 256 megabytes, which is very important. But the most important thing is that it's reliability. You are always sure that the measurement that you took at your device has reached its destination. The data was transmitted. Because it has this QoS, this is called the quality of service. At most once, at least once, exactly once. So using LoRa, using MQTT, you make sure that the data is transmitted and you are sure that it's transmitted. It's a messaging protocol. MQTT, and please write this down. In order, just to remind you, in order to get your certificate, you have to answer some questions, and one of the questions is about MQTT. Okay. MQTT stands for Message Queuing Telemetry Transport. Extremely simple and lightweight messaging protocol, subscribe and publish, designed for limited device and network with high latency, low bandwidth, or unreliable network. So you have the device, you have the MQTT broker, the subscribing device. So let's say, for example, here, we have a fridge here that sends data to the MQTT broker, and then it sends the data to our mobile device. And we can also see here, at the computer. Also sends the data here. At the same time, this computer here tells the fridge, sends a message back to the fridge, and tells it to do something, for example. Could be a fridge, it could be a door, it could be our thermostat in our boiler, etc. So it's a messaging system. So through this MQTT broker, you read messages and you send messages. You subscribe to messages, etc. It's a publish subscribe model. Another thing that we have here is middleware. As you saw before, in order to have various brands, various operating systems, different frequencies, different transmission protocols, different wireless transmission protocols, it's important to have the so-called middleware. Through this middleware, the middleware is able to connect all these similar things. It is able to manage our devices. It is able to connect to multiple brands. For example, ideally, and then sits between the producer of the data, and our application. So it is in between the IoT devices and the users and rules. Here, you kind of see here that for middleware platforms, you have all this here. IoT platform, edge management platform, databases, other IoT middleware. You have hundreds and hundreds of organizations and companies involved in the IoT. You have names like Microsoft, Siemens, Honeywell, ABB, Cisco, Google, Oracle, IBM, Bosch. There are dozens of companies. You have also remote access, AR, VR, digital twins. We will talk later about digital twins. Security is important. So, as you can see, there are hundreds and hundreds of options out there offering the applications, offering middleware platform, offering sensors, offering so many things. So it's not easy to decide which sensors, which platform, which operating system, etc. For someone who doesn't have the necessary experience, because believe me, it's very complex, and as times goes on, we see more and more and more companies and startups trying to get onto this Internet of Things trend and Internet of Things train, let's say. And believe me that this is just a glimpse of the actual size of providers and what they actually offer. Okay. There are hundreds of options out there, but the big players are like Microsoft, like IBM, Cisco, Amazon, etc. Okay. So a simple IoT architecture is like this. We have the things, you have the sensors, the gateways, etc., as we mentioned before. And now we have also the cloud. We talked about the sensors, we talked about middleware, and now we have the cloud. Not everything is in the cloud, and we have to know what the cloud is actually doing. So the cloud is offering a centralized platform for storing vast amounts of data generated by your IoT devices. Just a reminder how many billions of devices we have connected to the internet. So imagine how much data is produced on a daily basis. So you cannot store them on your computer. You need a lot of space. A lot of data means it needs advanced data processing. A lot of data and hundreds of sensors, thousands of sensors installed on a daily basis, it means that you need something scalable. And also, through the cloud, it helps you for the device management. As I mentioned before, one of the big players, a couple of these big players for Internet of Things is Microsoft Azure, Amazon Web Services, and we also have Google Cloud. All of these are offering different, these are the big players, okay? There are hundreds of other options out there. And believe me, it doesn't mean that they have, because they have a big name, they offer the best service. No. Or a smaller company could possibly offer something much cheaper and more customized to your needs. Okay. Usually these big players, they offer, let's say, everything, all in one solution. We have everything, they have everything, but many times they charge 10 times more compared to other companies. They are big names. They don't need someone to advertise them. But believe me, they are expensive. One sensor could possibly cost dozens of euros per year or 100 euros per year if you host them directly to them, depending, of course, depending on the frequency you have the data, etc. But the good thing about them is that they are reliable, they are easy to upgrade, they are, I would say, generally I would call them secure, okay? And reliable means reliable connection and availability, but at the same time reliable that they will not close the next day or close in 6 months from now, and you have to start from scratch, and what you have invested for a smart city, the company has closed down and you are left with nothing. So you have to balance things. So these big players are there forever and ever. So what are the predictions for 2025? It is predicted that we'll have 27 billion of IoT connections by 2025. It is expected to have $3 trillion revenue. Trillion, the IoT market. It is expected that 45% connections for IoT will be with connected cars. I think there is a new film now in Netflix. I've seen it. And some hackers took over some networks. And they managed to have access to these Tesla cars, hack them, and they were remotely controlling them and making them crashing to each other. So that's albeit remote, that's a possibility that what could happen if something goes wrong with security, okay? And we have seen other cars that people are hacking them. So a car, I would call it, is a interesting example of something that has hundreds of sensors. And now it is connected. The new cars are connected to the internet. You can start your car using your mobile phone. You can see the temperature within your car. You can see the fuel gauge, another thing within your car. You have an alarm system within your car, and you get notified instantly on your mobile phone if something goes wrong in your car. So car is a typical, like smart home. A car has much more sensors compared to a smart house. So please consider the car as a connected system of many sensors, okay? So you have very big challenges for IoT. Like, as we all know, you will have all these sensors producing data. But are all those data important? Okay, and which are the important ones? Do you have to store everything? Or do you have to store the important data? And what's important and what's not important? Data security is important. Data reliability is important. So these are quite the big challenges. That's why we have IoT data analytics. IoT devices generate large amount of data continuously, which is often referred to as data in motion due to its real-time nature. Store, blend, and manage time series data. IoT analytics involves storing and managing time-stamped data. So it's important to analyze the data in real time and also have bidirectional communication between the endpoints. IoT analytics deals with the increasing data volumes. The complexity of managing and analyzing this data grows, which in turn drives the need for more sophisticated automation solutions. So it is important for systems to automatically analyze data. So IoT devices produce data, a large amount of data. People, they cannot process them manually, so we need systems to analyze them automatically. As an example, we have here smart home, intelligent transport system. They are connected through edge devices here, at control this layer here, using Wi-Fi, cellular, wired, or Zigbee. And then we have the cloud. And then in the cloud, we have machine learning, classification, anomaly detection, online learning, etc. So this is a typical IoT example. And as we said before, IoT consists of IoT edge devices, servers that are closer to the data sources. A typical, as I told you before, I told you about Microsoft Azure. And you can see here a typical, we have sensors here, facilities management, connected manufacturing, connected cars, etc. We have stream injection here. You have analytics here, analytics processing. You have transactions here. You have storage here. You have here the digital twin. So that's why I said before, these large platforms like Azure, Microsoft Azure, and other platforms, they offer all-in-one solution. They are good, but many times they are expensive, and they also give you the ability to make apps, logic apps, insights, etc. So AI, machine learning, deep learning, etc. It's important part for Internet of Things. So deep learning and machine learning and artificial intelligence, they are not the same. Not the same. They're different. So you can have a look at what is the difference between them. So you can have AI and machine learning for IoT, for agriculture, for example, for healthcare, for increased yield crops, for continuous monitoring of patient living conditions, facilitating timely and personalized care. Okay. And now we have digital twins. Imagine this term digital twins is, I will not say something new, but for you, it could be something new. There is a video link here. I don't know if it's possible to see the video. You can see the video later. It's talking about the digital twins. It's quite a long video. Maybe we will share it later. And what is a digital twin? Imagine that we have thousands and thousands and thousands of sensors measuring every part of our city, measuring the environment, measuring the road traffic, measuring the temperature, etc. But at the same time, we have so good design models that they can mimic any change that we have in the city to mimic the real thing. For example, what happens if we change those traffic lights? What happens if we make these streets one-way streets? What happens if we plant more trees in that area? What happens if we have high-rise buildings in that area? What will happen to the airflow? What will happen to the microclimate? So imagine that a digital twin is ideally, there is still a lot of work to be done for this. Ideally, it's a city on which you can experiment, do things, change the traffic, plant trees, etc., with testing your idea, testing your hypothesis before applying it in real. So ideally, a digital twin, and for this example, we have a smart city. It resembles the real city. It behaves as a real city, and allow us to experiment. So we can, using the IoT, you can measure data. We can have also, using the digital twin, we have serving and mapping data in the digital twin. So IoT sensor, we have data from sensors. We have data from infrastructure. We have from emergency services. We have other data. So we have hundreds and hundreds and hundreds of data to make this city. This is, there are some initiatives to do this digital twin. I believe that there is a lot of work to be done before we actually reach this, but for simple things, smart city is very complex. For simple things like a digital twin of a room to see what happens if I open the window, what happens if I open the door, what happens if I leave the lamp open, switched on, etc. For simple things like a room, a house, you can have a digital twin of a house, a digital twin of a room, a digital twin of a car, a digital twin of an engine. Imagine all these exact replicas in digital format to replicate in a large scale. So if you can have digital twin of a room, have a house, then you can have a high-rise building. You can combine all this, house here, house there, and then you can build a city. But it's quite complex thing, and it needs a lot of processing power. IoT testing and quality assurance. So we are happy we have installed our sensors, and our sensors, they seem to be fine. But how do we know that they actually work? What is their performance? Do they perform as expected? How do we verify that they are connected? How do we know that the battery is not dead for whatever reason? So we have to make testing and quality assurance of our network, testing and quality assurance of our Internet of Things. I mean, not for our house. We do not need quality assurance for our house, but for larger applications, for a smart city or a production line in somewhere, we need to make sure that we have quality assurance. Another thing which is important is IoT device lifecycle. So let's say that we need for a smart city 10,000 devices. Are we going to manually insert the device into our system? What is the onboarding? And this is the onboarding. The initial setup and registration of IoT devices onto a network. And the provisioning. Is it going to be manual? Is it automated? Is it using a QR code? Is it by importing a special script that will enter all these things somewhere? So it's important. The configuration of the device, diagnostics of the device, if they are functioning correctly. Test some things if they are secure, if the devices are secure. Have we got a new firmware for the device, a new software for the device? How can we upload that to the device? Is it easy to, or do we need actual physical presence to connect the device and upload the new software on the device, the new firmware on the device? What happens at the end of life? In 3 years, in 5 years? So again, we have to consider the whole life cycle when we install something. 3 years, 5 years, 10 years. Many IoT manufacturers promise that they have batteries that they last for 5 years. And then they actually what happens is that people who install them, they discovered that it lasted only for 9 months, for example. Why? Because it says in the manual somewhere it lasts for 5 years if you upload 4 times per day the temperature, and the gateway is 10 meters from you, for example. But in real life, you will need to upload every 15 minutes, for example, instead of every 4 hours or 5 hours. And the gateway could be 2 kilometers away from you and not 100 meters. So you need more power requirements. And I've seen many comments in the internet that the manufacturers promise 5 years of battery life, but actually it's much less. So you have to be careful about this and where to put gateways, etc. So there are many challenges for deployment of IoT. And then we have attacks on the Internet of Things. Imagine if some hackers, for example, we have in our smart house, as an example, everything is connected to the internet. We have sensors everywhere. All the sensors are connected. We can see this on our mobile device. We are happy it is secure. And then you have some hackers going there, tampering and spoofing your system. You think that everything is okay, but the hackers have actually disabled your devices. Your devices appear to be connected correctly and sending data correctly, but what actually happens is that some hackers and some thieves have done this. Okay. So an intruder or tampering and modifying the code of data within IoT and environment networks. Yes, it is possible. It's not impossible. So we have here example of attacks. Most of the attacks here, you can see here, they are not physical attacks, but this here is physical attack. I would say that the most important attacks are here. They are not the physical attacks. They are the software attacks. They find a vulnerability in the software and they automatically distribute something like a virus to the devices. So these are challenges for IoT. Lack of resources, unclear job roles, legal liability, insufficient knowledge, etc. Insecure network service, insecure data storage and transfer, insufficient private protection. There are so many security issues with any device that is connected to the internet. So by having in mind that IoT devices are connected somehow to the internet, like your mobile phone, like your computer, it means that it is possible for someone to take over and intervene and do something with it. Okay, we have